Hello everyone. In this video, we are going to talk about group frequency distribution tables and how to create them. Before we begin, it's important to understand why we use a group frequency table instead of a regular or ungrouped frequency table. Typically, when the number of observations in our dataset or the range of the dataset is large, it can be difficult to effectively summarize our data using an ungrouped frequency distribution table. Additionally, when our data is continuous, it's often that each observation doesn't repeat and is unique. So each frequency would just be one, which isn't really an effective way to summarize our data. Therefore, using a group frequency distribution table can be a much better solution. We are given the rainfall in 20 cities, and we want to construct a frequency distribution table with 5 classes. We first want to start with a table with 4 columns. The first column are classes. The second column is the class boundaries, but we will just denote this as boundary. The third column is tallies. And the last column is frequency. We want to start by finding the range of our dataset. So the largest value is 4.8, and the smallest value is 1.7. So the range is just 4.8 minus 1.7, which is 3.1. We then want to find our class width, and we can do this by dividing the range by the number of classes. So the width would be 3.1 divided by 5, which is equal to 0.62. One very important step is to round up our width. We should do this such that the new width has the same number of decimal points as our dataset. So our dataset has 1 decimal point, so we round this up to 0.7. Now that we found the class width, we can use this to find the lower bound of each class. So the lower bound of the first class is simply the smallest value, which is 1.7. Then we can use the width and add it to find the lower bound of the second class. So the second class would have a lower bound of 1.7 plus 0.7, which is 2.4. Then the third class would be 3.1. Then the fourth class would be 3.8. Then the last class would have a lower bound of 4.5. The upper bound of the first class is simply the lower bound of the second class minus 1 unit of precision. In our case, since we have 1 decimal point, this would be 0.1. If we were working with whole numbers, this would just be minus 1. And if we had 2 decimal places, it would be minus 0.01. So the upper bound would be 2.4 minus 0.1, which is 2.3. Then to find the rest of the upper bounds, we can just add our class width. So the upper bound of the second class is 2.3 plus 0.7, which is just 3. Then 3 plus 0.7, which is 3.7. Then 3.7 plus 0.7, which is 4.4. Then the last class has an upper bound of 4.4 plus 0.7, which is 5.1. We've essentially created 5 even groups to fit our data in. We can see that there's a gap between each class. There's clearly a gap between 2.3 and 2.4, and 3 and 3.1, and so on. So if we want to use this table to create something like a histogram, then there will be a little gap between each box, which we don't really want. Therefore, we need to define a class boundary, and we can do this following a simple procedure. Take the lower bound of the second class, which is 2.4, then subtract the upper bound of the first class, 2.3, then divide by 2, and we get 2.4 minus 2.3 over 2, which is 0.05. Then take this number and subtract it from each lower bound and add it to each upper bound. So for the first class, we find that the boundary is 1.7 minus 0.05, which is 1.65. And then 2.3 plus 0.05, which is 2.35. For the second class, the lower bound is 2.4 minus 0.05, which is 2.35. And the upper bound is 3 plus 0.05, which is 3.05. Applying this to the rest of the classes, we get, for the third class, it's 3.05 to 3.75. For the fourth class, it's 3.75 to 4.45. For the fifth class, it's 4.45 to 5.15. Essentially what we've done is we've turned each upper bound to the midpoint of the upper bound and the lower bound of the next class. This leaves no gaps between each class. Next, we want to tally up where each observation falls within each class. So our first observation is 2.3, which falls into the first class. Then 3.1 falls into the third class. Then 2.7 falls into the second class. Let's do this for the rest of the data set. This is a tally of our data set, and we can use this to find the frequency of each class. So the first class has 5, the second has 4, the third has 6, the fourth has 4, and the fifth has 1. Typically, a group frequency table only has the columns classes and frequency, but we can use boundary when we're creating a histogram, or it can be used when we have more precise data. Additionally, tally is more used as scratch work, but it's really helpful when counting up the frequencies. I hope you enjoyed this video, and if you learned something new, make sure to subscribe.